Hello everyone, my name is Ryan Lingo. I'm a geology and environmental science major and a meteorology minor at California University of Pennsylvania. Today I'm going to talk to you about my investigation into the migration of three tree species, the black cherry red maple and shagbark hickory. So my hypothesis are the black cherry Prunus serotina red maple Acer rubrum and shagbark hickory Carya ovata tree species migrating to different geographical locations. When we think about trees migrating, they're not actually the canopy or the older trees aren't just getting up and moving. It's more so the saplings that over the years are going to slowly start shifting to a different latitude or longitude. So depending on the climate variables or ecological disasters or anything of that sort can actually move trees because they're going to go where they most can prosper. So wherever they can prosper, that's where they're going to shift to. So I have this little comic here. You guys can read it over. Thought that would give you a good laugh. It just kind of is talking about how species are starting to move to different locations, which I thought was kind of funny. So my data source is from the U.S. Forest Service. It is the Forest Inventory and Analysis National Program. This program basically is a huge census, millions of records of all different types of trees. These records were extensive. There was so many different fields, so I definitely had to modify the data while trying to do my research. The records would have been too large. So modifications that I did, first we had to search for the specific species of trees. Like I said, there were millions of fields, so just deleting these fields, getting everything organized took a good day or two. So we create tables with object ID, the PLTCN, SPCD, and DIA of each specific species. The object ID represents the specific tree. The PLTCN was used to join our field to a summary table. The SPCD was the species type, so what kind of species. You can see at the bottom you have Carya alba in the left-hand image. That would be the species. And then the DIA of each specific species is going to be, so you have a point. Each point represents multiple trees, but to represent them we have to make sure we have every single tree that's in that point. So that's how we did that with our modification. So our analysis, we're going to measure geographic distributions of black cherry red maple and shagbark hickory species pictured below. This should give you a better representation of what each tree type looks like. Maybe you've seen it if you're from the East Coast or a little bit the Great Lakes area. You've probably seen one of these trees. So here is the distribution of the black cherry canopy and sapling. One thing to note here is the radius of the circles is dependent on the type of the age of the tree. So the canopy is always going to be smaller because it's had ecological disasters, climate change, anything that's going to kill the trees off, like people building homes or human population growth, that'll cut down on trees because the canopy is going to be needed to be cut down. Saplings are going to be a larger number, a more vast number, so we have the bigger circle every single time. So you can see the egg shape, the directional distribution here, the ellipses you see, it can't really tell me anything. I can't see if a tree's migrating from this. You can see the mean centers, which would be the lighter colored tree here, that is the saplings, and the mean center of the canopy of the black cherry is going to be the brown and green tree. So we can't tell any kind of migration from this, but that's what we started with. So the red maple canopy and saplings, still nothing. The mean centers look like they're telling us something, but we can't be sure because our directional distribution, it doesn't show us anything. It just shows us two circles overlapping and not really any kind of movement. So the shagbark hickory, out of all the distributions here, had the greatest change in its circle radius and distance from each circle. So you can notice in Milwaukee and Kansas City, the circle has shifted to the northwest significantly. So we think there could be something going on here, but still not sure. The mean centers of the saplings and the canopy are extremely far apart. So that looks about to be, it's jumping a state, you can see there, from Louisville all the way to Illinois. So something to note there with that. Analysis continued. After that, we created kernel density maps for all three species to see how they're distributed across the country. How does each kind of tree hold up to different environmental impacts? So you can see here the black cherry. Saplings are always going to be in greater number. Like I said, it's a newer tree. They're just born, so they're more resilient. They can shift easier, and the canopy has been through more things. It's the older tree, so there's less of them. So you can see the distribution. The red represents the canopy, and then the blue colors represents the saplings. So the distribution of our red maple canopy and sapling, you can see it's a more widespread tree. You have the canopies in certain locations. Still, maybe some deer or something are eating or killing the trees. Something's happening. We don't know. Um, the distribution of the shagbark hickory canopy, you can see with this tree, we had very sporadic our canopy was definitely very sporadic. So could that be something with the people who collected the data? I don't know. I'm not sure about that, but you can definitely tell that the saplings are definitely more congregated out west, which, like I said earlier, we saw that northwest shift. So could that be something of a migration? So we're going to take all 6 kernel density rasters and rescale them by function. Like I said, there's always going to be more saplings than canopy. So after we do this, we're going to use a raster calculator to compare the sapling layers to the canopy layers. So we're just going to subtract saplings from the canopy. Our positive values are going to show us an increase in tree species. Values near 0 will see no change, and negative values will see a decrease in the tree species. So looking at the black cherry, you can see here the red colors are positive, so we're going to see an increase in species up by the Great Lakes, all the way into western Pennsylvania. And an interesting thing to note here is along the Appalachian Trail, we see kind of this advance of the black cherry tree population. I think further research would need to be done to see what's causing that and where they're moving to. So the red maple, we can see decreases in the Great Lakes, decreases up in the Northeast. Near Philadelphia, New York, Pennsylvania, we can see all these increases in the tree species of the red maple. And our shagbark hickory, which seems to still be that sporadic kind of canopy. You have these light green dots, which means there's going to be a decrease. But then out west, you see this large expanse of increasing species, it seems, because positive values show increasing species. So the shagbark hickory seems to be the winner. So concluding, the black cherry trees will see a shift toward the east coast and from the Ohio Valley, northeast, northwest, and southwest. Red maples will see a slight decrease in trees near the Great Lakes and an increase in the northeast, with a decrease in species in the southeast. So it seems shagbark hickory could be our winner here. It'll be migrating over 100 miles from near Kentucky to Illinois. That is a 100-mile jump in a species. So there's definitely a lot of future research that could be done with this. Like I said, I'm a meteorology minor. I would love to do a climate analysis, see maybe what's causing these specific tree species to move. Could it be temperatures, wind profiles that are changing, or anything that could be caused by climate change? So a lot of future research could be done with this. So we're excited. The above predicting abundance of 80 tree species following climate change in the eastern United States was used to pick tree species that we thought would have the best chance of migrating to a different location. There's a lot of different models out there, but this one was the best that we found, so very helpful there. Questions? Thank you for listening. If you do have any questions, feel free to email me at either one of these emails. I will be ready to respond and give you the best answer I can. And then here's another image I have here just to kind of get your minds thinking. Did you know a tree can absorb up to 48 pounds of carbon dioxide a year? Plant a tree, reduce global warming. It's the best way we can kind of fight climate change or the global warming. So if you do have any questions, please let me know. I hope you enjoyed this presentation. Thank you to everyone who helped me, including people from the Carnegie Science Natural History Museum, for giving me some type of identification and some thought on where I should go with this project. So thank you to everyone, and I hope you enjoyed.